I believe we can go ahead and get started. Welcome and good afternoon, everyone. Thank you all for joining our Terragraph Essentials with Siklu by Ceragon, Design, Configure, and Deploy Next-Gen Wireless Networks webinar. Here to present from Siklu by Ceragon is their Director of Network Development, Timothy Murphy. If anyone has any questions throughout the presentation, please feel free to add them into the chat and they'll be addressed at the end of the webinar. Tim, you're up.
Okay, thanks a lot. So what we're going to cover here is mainly focused on Terragraph. I will talk a little bit about the other devices that Siklu has, just so you can kind of see how they may fit in together. So let me just kick this up. Okay, this is just a marketing piece of gobbledygook. Kind of talks about what Siklu has done, but I'm just going to, this is a technical, not a marketing discussion. Here it is what Siklu really has done. It's really advanced the industry. It has over 40 patents from everything from chip design to the way millimeter wave is used. Okay, but why millimeter wave? What's the reason? Why not just stick with 5.8? The problem is 5.8 is growing out of control. Literally, it's doubling every 2 years. When I started talking about this stuff, we were under 50 million APs globally. Now we're over 1.3 billion. It's insane. Okay. What is millimeter wave? Okay, what it is that you essentially have right here is right here is what the band we're talking about. Here's your licensed Wi-Fi, unlicensed Wi-Fi. You've got your TV channels here, visible light is over here. So what it really is, it's two bands. It's V band and E band. V band is 60 gigahertz. It's unlicensed in the US. E band is lightly licensed, really easy to get a license. Takes, literally a matter of hours. And it's good for 10 years and the fee is really low compared to the other one. The key thing though with millimeter wave is you need to have line of sight. Whether you're talking Terragraph or point-to-point microwave, you need to have line of sight. That's critical. As far as what limitations you have, rain fade, because in the way multi-point works, rain fade's not going to affect you that much. In fact, it's going to have very little effect. Where rain fade really comes into play is your longer distance links. In fact, we'll actually look at a little bit more down in the beginning, but let me kind of go over here. How did it begin? Millimeter wave was literally invented by the name of J.C. Bose in 1895, and it's been going ever since. It's been slowly progressing. Keep in mind, in World War II, they tried making it work, but there's no analog equivalent. In fact, that's one of the things that really differentiates out millimeter wave from other bands, because there is no equivalent in analog. There is no multipath. There is no flat fading. So things that you're used to dealing with doesn't exist. Where has Siklu done? I mean, we started with the concept of making the first all silicon chipset of 4 millimeter wave. Before that, everything was discrete componentry. The two advantages to getting one piece of silicon for your RF is that greater lifespan. Before we existed, lifespans were between 5 and 25 years typically for mean time before failure. Price on a link, typical link, was $45,000. With Siklu changed the world when it introduced its first radio in 2011. Our first gen unit was $7,000 for a full 1 gig link. It was, rather than the 5 to 25 years, it was 70 years mean time before failure. This revolutionized the industry. Siklu in 18 months became the largest millimeter wave manufacturer in the world. Here's the band, literally, and this is the reason why millimeter wave works so well, is that down here, and this is accurate as in terms of how much bandwidth is available. This is your 5824, even your huge 6 gig spaces right there. This is millimeter wave. It's giant. There's so much more to utilize. And that's going to be the huge advantage to millimeter wave. There's just simply more real estate. Okay, factors that count, okay? Rain fade when you're talking about distances, and oxygen absorption on the lower channels, but it's not everything. And I'll show you something what I mean by that. Things that don't count: interference, multipath, and I say interference with a asterisk because when you start doing ultra high density networks like you see in Terragraph, you do want to start seeing some things because you're now scanning over a 90-degree area to cover multi-point, and you do want to have some mitigation for potential interference at very close ranges. But things like fog, power lines, dust, snow, that's when the big fluffy stuff doesn't affect it, okay? Fresnel zones, okay, that's the other huge advantage. This Fresnel zone is less than a third the size of a 5/8. This is really important because now you can take a signal under a canopy, still get line of sight. We do this all the time with those big magnolias in the south, and we shoot underneath. Over in Asia, we go underneath trees all the time. Again, as long as you're above 15 meters above, and roughly like to be or 15 feet or 5 meters above the street, you want to make sure that you give yourself probably another half meter above that or 17 feet. That way you clear all the vehicles. And millimeter wave can do this trick. 5A has a very hard time with it, okay? And by the way, just on a short thing on Fresnel zones. Fresnel zones are purely determined by distance and by frequency. Some people think, oh, I can shrink the Fresnel zone by using a bigger antenna. No, that doesn't work. If you don't believe me, go to a Fresnel zone calculator online. It's going to ask you for two things: frequency and distance, period. So how does it do it? It's because the way it just simply has more real estate. In one band of a Terragraph channel, which is 2,160 megahertz wide, that's more bandwidth that's contained in all of sub-6, including the new 6 gigahertz channel, just in one of our channels, okay? That's the reason. Tons of spectrum. You've got pinpoint accuracy with really small Fresnel zones. Even on scanning antennas, you've got incredible accuracy, okay? Basic guidelines for millimeter wave. First off, it is link on point to multi-point is that you really, first off, if you're planning it for the first time, we really get us to provide you 4 hours of professional services. Let us help you set up that initial network, especially with Terragraph. There's a lot of moving parts. It's not as simple as our earlier multi-point units because it does more. It has greater throughput, and therefore, and it has greater security. Therefore, it's going to take a little bit more and a little more planning. Also, make sure that you go through the quick config guide. It's available on our partner portal, and we always update it with the new generation of software. We actually combine 3 documents into one document to make it work. The other thing to remember is only use shielded category cabling, and you want to make sure that you're using shielded connectors, and make sure you're doing outdoor rated stuff, even though you're running some stuff indoors. Make sure, and the reason why you want to do this is because it gives you well, one, you're going to violate warranty if you don't run shielded cable. But 2, it also creates for a more secure and stable network. The other thing I want to recommend is that you start looking at cable certifiers rather than just standard cable continuity testers. And the reason for that is when you start getting into throughputs above 1 gig, and all of our Terragraph units, except for our 2 small guys, all run multi-gig RJ45s. And you're going to notice, not just in our devices, but other devices, that you can actually have a connection, show a connection with a continuity tester, but it won't pass the signaling that you need with a multi-gig port. Okay, keep that in mind. You just want to make sure you take these steps. It's really important. Accuracy is everything. The one thing you never want to call up us and ask us, well, I think at the distance is, you want to know plus or minus 3 meters or 10 feet. It's really critical you know your distances. It's really important. You also, when you're planning this, like using our WiNDE tool, you want to make sure your points that you're trying for accuracy, you're not just kind of plopping them on a map where it is. You want to be within 1 meter or about 3.5 feet of where the point is that you're going to. It's, again, really critical in planning out a network properly, okay? Near line of sight does not work. If when you're looking at an area, plan for future buildings, vegetation growth. Make sure that you have line of sight today, but also where line of sight will be in 5 years. Make sure you look at that, because that is so critical. Because we get calls all the time where people say, my link doesn't work. It's been fine for 3 years now, it doesn't work. We have them look at the path and they see, and it's because a tree grew or a building got built. So make sure you plan for the future of your network point connections, okay? It is really key that in the network planning stage that you just don't arbitrarily put things up. You want to have it as a probable line of sight. And then you want to verify those line of sights with an actual site survey, okay? Where would you need millimeter wave? What are the use cases? It's everything from smart cities to, campus environments. I mean, we do networks all the way from US National Mall is all secured by a Siklu millimeter wave network, the Statue of Liberty, NASA. We do a lot of 3-letter agencies and things like the Secret Service, but we also do like school districts and retail and strip malls and everything in between. The key thing is that providing that stability and reliability and capacity of the signal, okay? What about fixed wireless access? Let's talk about cellular 5G. The problem with cellular 5G is that it's just plain old capacity. You have to compete against all the cell users. It's not consistent, and the latency is just simply not there. Even, you start talking about 5G, they say, oh, well, we can get down to a gig. Well, or down to 1 millisecond, and we can get up to a gig. I've yet to see any cellular system get down to those things that they've claimed. Okay, so just keep in mind, will cellular get there someday? Yeah, but they're not there now. Okay, it is more reliable, more stable than any other band. Okay, what do we have in terms of solutions? It's our 8010 as well as our 2500, our point-to-point E-band microwaves. Then we've got street level, our 614s, which are used literally in so many secure environments. This is what we use on the National Mall. This is what we use on the U.S. Capitol. This is what we use in a lot of critical places because it's just a guy that works. Then we have our older generation point-to-point, which still does some tricks that are pretty cool that even the newer Terragraph can't do, which is that it can track at 60 gigahertz moving objects, roughly at about 40 miles an hour is what we've tested it to, but it does work. Street level, if when you go to Terragraph is just, it's the next generation. It is at minimum 1 gig full duplex, okay? And I say at minimum are what we call our minimum distance specifications. You follow those, you'll at least get 1 gig full duplex. And it's very stable and very reliable, okay? Distances, you're talking about TG, we're talking about 230 meters, okay, for TG. That's our recommended max distance for multi-point, not point-to-point. And there's ways you could also exceed it by going a multi-point to a fixed point. That's a T280 that can go out to, with a 6-inch dish, to about 320 meters, with a 1-foot dish about 430 meters, okay, from a multi-point, okay. 1200 710s, pretty much 1-foot dish 1 mile, 2-foot dish 2 miles. 2500 can be pushed out a little bit farther, but it was designed for long distances. And 8010s, we've got those, especially when you combine it with our extended M feature, you can take a 8010 all the way out to 10 miles using an 11 gigahertz backup, which works really well. The 614, the 600s, again, have been such a smart player for us. And then we've got the 2500, and then we have the 8010. These are all really superb radios, great backhaul. And this works well for backhauling Terragraph systems as well as others out there too. Okay. Extended M, this is how we get those distances using that secondary radio. And the nice thing about it is it doesn't fix you into an existing radio system. You don't have to, like for example, if you have an existing 11 or an 18 gigahertz radio and you want to upgrade it, you just put a 8010 on top of it, plug it into the extended M feature, and all of a sudden you upgraded your 11 and 18 gigahertz your microwave connections to a very high speed millimeter wave at those distances. Okay. We also do heated antennas for when you have areas that ice up, and it's just not Alaska. This is like New York City is a place where you get this freeze thaw, and you start building up ice on it by doing a heated antenna. You prevent ice buildup. And then we've got a dual band antenna. So if you're trying to do two bands, 5/8 and millimeter wave at E-band, you can put it in a single antenna, and that way you save mounting costs and monthly roof rights and rental. Okay. The topologies that we do, essentially what we talk about is hub and spoke, which is the most common, ring, which we've got a lot of good ring topologies that can be used, and daisy chain. Daisy chain is typically, as most of you know, it's the last route you want to go. But the problem is that oftentimes you have to do several hops to get to a point you need to go, especially when you're talking about getting through trees and whatnot. The advantage to daisy chaining with millimeter wave is millimeter wave has the lowest latency. You know, when other people say, well, we're only 7 milliseconds. Well, stuff we're talking about is sub-millisecond. We're talking about 0.2 milliseconds. Okay, so you can do like 6 hops of ours, and you're still way below what the other folks can do in terms of latency. And the other thing is signal reliability. It's more stable. Okay. Other applications for, especially when we talk about E-band stuff, is we can extend a fiber network. We do this all the time where fiber networks will be, either deployed, or let's say we advance the build. Like we just did this for the Washington State Convention Center, and they couldn't get a 10 gig circuit in downtown Seattle. And it turned out that they were 18 months out. We got the link up within a couple days, and it worked so well, they ended up buying only a 1 gig fiber circuit to back up the main link of the 10 gig 8010. Fiber backup, we're used all the time for that, and also to close rings, especially when you're going over things like highways, railroads, things that you have to get right away access to. Again, it takes forever for fiber. With ours, it's no problem. Okay, so the Terragraph, this is the main focus of this whole discussion, is that extensive testing. We are probably one of the most tested radios in the market right now, especially when you start talking about Terragraph. Whereas most people are still working on their first generation Terragraph, we've already have out in production our second generation. Our N367 is our second generation TG device. And we've really take what we've done with TG to new levels. So I talked about earlier about what channels should you use. If you look at this chart here, you'd say, well, my lowest one is channel 4 and the worst one is channel 2. Well, in multi-point, especially dealing at about 230 meters, your channels 4, 3, and 2 are roughly about the same. It's actually channel 1 that'll give you less performance. In fact, probably about 30% less performance, because there's other factors to play other than just oxygen absorption. When you're talking about point-to-point at distance within 60 gigahertz, still channel 1 will be your lowest performance. Channel 2 won't be as good as channel 3, and channel 4 is where you get your maximum performance. But you're really now talking, distances of 5, 6, 7, 800 meters, okay? So what does the portfolio in Terragraph look like? So the portfolio consists of this. You've got right here, you've got your, this is the N367. It is 4 90-degree sectors. you don't want to think of it as an omni because it's not. It is 4 90-degree sectors connected by a 10 gig switch at its core. And it has a 10 gig RJ45, a 1 gig PoE out, and a 10 gig SFP plus. And this is a really capable, it's a very powerful networking tool. Each sector is capable of doing 15 clients per sector, okay? You want to, then we've got over here, we've got the single sector units. This is the N265. It's like having one sector, the N367. And then you have the T265, which is the client side. And then you have our smaller guys, the T260, 261s. The big difference is T260s are made in Israel, T261s are made in China and a little bit less expensive. And that's the other thing to remember with our Terragraph. We're one of the few, in fact, I think we're the only Terragraph one still that is not made in China. We are all made except for the 261 in Israel, which means we're TA compliant. Okay, huge difference. And then you have the point-to-point ones, which is the T280. But remember, the T280 can also act as a client device to the N367. So let's talk about the smaller guys. We've got the T260 and the 261. The big difference between the two is that one's made in China and one's made in Israel. One is TA compliant, and the other one is really cost effective. They both have the same performance quality, even though they're smaller. And in fact, the slowest thing on the units is the 1 gig RJ45 connection. The RF section in both of these radios actually exceed the performance characteristics of a 1 gig RJ45 port. So it gives you the true equivalent at 230 meters of just like a piece of copper, a piece of fiber at 1 gig. With the ports, as we just talked about, the 10 gig RJ45, 1 gig PoE out. And by the way, that's the 802.3 BT. It is literally the latest generation of PoE out. It really is effective. You can actually run its whatever power. The unit itself takes 47 watts. So if you put a 95 watt PoE in, you now can get, you're now talking up to 48 watts of power on the T265. If you put a 95 watt on there, that takes 27 watts of power. That means you're now talking about something that can do 68 watts worth of PoE out power. Really impressive. Okay. What's the core of multi-haul and why does it work? Essentially, you've got two types of main devices. You've got DNs or distribution nodes. That's what an N367 is. This is what sort of controls the network. When you're setting up a network, you want to make sure that you know exactly where it's pointed. And typically what we'll do is we'll set up the 4 sectors as channel 2, channel 4, channel 2, channel 4 going around. And then you want to make sure, obviously, you need 2 radios, always need to talk on the same channel. They can't be at different channels. So it's really key if you have a DN like an N367 talking to another N367, you want to make sure you have the same channel pointed on the same record, for the same radios. So you'd have like a channel 1 or sector 1 that is on channel 2, talking to a sector 3, which is also on channel 2. Okay, sometimes it's a little bit hard to wrap your head around, but if you think of them as 4 individual 90-degree sector radios connected by a 10 gig switch, that will help you out. Now, what the advantage here is that we eventually are going to have a fully functioning ring topology. Now, we're different than other folks that have existing systems that use what's called OpenR and Terragraph. We don't use OpenR. OpenR is a layer 3 platform, and the problem with OpenR is that you have to change state, in other words, to program a unit or to, in a failover situation, to change to another route, you have to have connectivity to your router. The advantage to ours, we're all layer 2. So the programming happens directly on the unit. So that means you can be plugged directly into a radio, configure the radio, and you can actually, work with the system without going to an outside controller. The other thing is you don't need an outside controller to change state. I'm not trying to say that if you lose connectivity in a standard OpenR system, if you lose connectivity, the system is going to go down. That's not the case. What happens is it just cannot change state. In other words, it cannot do failover, okay? The other thing is with this system is that the DNs can talk to DNs, and this what can create rings. The client devices are always just essentially point to multi-point. It's just a hub and spoke system, and it goes to the individual client devices, okay? You can also do point-to-points either with a T280, which can get distances up to 1,200 meters, or you can use a MPL 260 or MPL 261. Very cost effective, but very reliable, and they'll go out to 230 meters. And that means if you're going down a few blocks across the street and you just need to get that quick 1 gig connection, it's the perfect tool, okay? So what's the advantage of going TG? It's a widely adopted industry standard. It has interference mitigation built into it. That's the big advantage. It's also based on the 802.11ay chipset. The older one was the 802.11ad chipset, and it's very cost effective, especially when you're trying to scale and you're looking at, let's say, a fibering out an area, or you're going to Terragraph out an area. Terragraph almost always will be way more cost effective. It's going to be super reliable and just as effective of what a fiber system can be. It is the nice thing about millimeter wave, especially 60 gigahertz, is it naturally decays. And people say, well, that doesn't mean it can't go very far. Well, that's a good thing. You get lower RF noise floors. When you're trying to do high density environments, it's a huge deal. This is not meant for farms in the middle of nowhere. This is meant for that small town near the farm in the middle of nowhere, or it's meant for cities or suburban, but it's designed for higher density environments. And that's the big advantage. Has an advantage over that, over any other technology, including some of the highly touted ones you see, which has, and some of that technology is really cool, where they do this long range noise canceling. That's cool, but it has limited in terms of scalability, especially when you start talking about high density neighborhoods. They don't work well in those, okay, because they just can't get enough, because they're limited to how much throughput they can get on that single panel. Whereas you can use with Terragraph, you can use a thing called densification. You can put lots of devices in high density environments and you can get incredible levels of performance out of it, okay? The 3 types of mitigation that exist with TG is, number 1 is polarization. You literally have an even unit, which is like a DN going to the client units, which are going to be odds, but also the next layer down of DNs would be odd, and the next layer out from there would be even, and they go even, odd, even, odd. That's number 1 is polarization. That keeps units from self-interfering with its clients, okay? Second is frequencies. With Terragraph, you've got 4 channels to work with, which is really, even in high density environments works really well. Again, because you already have polarization, using 4 channels works really easily. And the third element you have is GOLA codes. GOLA codes are common in other types of communications, but it's very rare you have to use them in the 1,000 or so Terragraph systems I've designed, I think, and have implemented. I think I've used GOLA codes like 3 times. So it's rare that you use it, but it's there as your, so you always have a way to make sure that you're not creating any interference, especially in ultra high density environments, okay? The differences again between what we do versus everybody else is we are native layer 2. We're not dependent on a network router. You can directly input via GUI or CLI, and you don't need to go to a network control at all. We're native IPv4. We're not IPv6. Translate to IPv4. We're native IPv4. And most of the radios, except for the T261, are TAA compliant, which is huge. Means if there's a project getting, most state and federal funding are requiring TAA compliance, okay? The thing is that going back to distribution in like the N366, N367, or the N265, they all can have 15 client devices or devices we call slots per radio, okay, that you program in. You want to make sure that if you're setting the TG systems, that you're just not programming everything at once. Best way to do it is to actually go in, program up the radio as you install them, the clients. So you go in with your client devices. What you do in the shop is you literally just upgrade the software, check that, make sure it's current, upgrade the software in the DNs, make sure that's current, and then take the DN out, and you have a guy on the DN and the guy out in the field pointing back to the DN saying, okay, I've got serial number, and you just read the serial number off, program in the serial number, and bam, that unit comes up. And there's no programming on the client side that needs to be done. Everything is done from the DN, okay? Couple of things you should never do. Never hit the select all button, because then you're consuming slots on each sector, which are it's consuming slots, which is not a good thing, but also it's making the radio go through and keep rechecking and looking for an empty slot on a radio, because it'll keep rechecking, and that slows down the performance of the radio. You don't want to do that. And you just don't want to have non-active radios that are programmed in for a future radio. Wait until the radio is ready to be installed. There's no reason to pre-program. All you're doing is causing the system to slow down, okay? Also, if you're going to do SSIDs, I'm going to make the case here, unless you're having to meet a specific requirement, let's say if you're doing a HIPAA system or something like that, which requires that you have unique SSIDs. The thing with our systems is that, first off, it doesn't broadcast the SSID. You can't take another device, even with the default SSID. The radio has to be pre-programmed in the DN in order for it to talk to that unit. Even if you're using the default SSID, it has no way to communicate with the radio. Unless it's programmed into the DN, there is no way to communicate it. If you are going to change SSIDs, do it at the end. Make sure your system's up and working. One of the top 10 issues we run into is people programming in the SSDs right out the chute, and they fat fingered a number on one of them, and then they spend 2 days trying to troubleshoot to see where the issue is. Wait until the system's up, working, operational, and if you want to change SSID, do the last thing before sign off, okay? And it's just a better way to do it, okay? The other thing is do the default names if you can. The big advantage to doing that, it makes it easy, it's easy to replace. And the thing is people will say, well, how do I know which one I'm talking about? Well, we have a slot there that shows that you can use location. You don't have to use the name or some special code in your names to know which location is. We can actually tell you, and I actually have a slot there that actually will tell you that you can enter in and what location you have, okay? GPS sync, this is critical. The DNs, not the clients, not the CNs, the DNs all have to see satellites. Uses GPS for coding, uses TDMA, time division multiple access, okay? You need to see at least 7 satellites. Now, those of you who are familiar with GPS, you know that it only takes 3 to get a GPS reading. The problem is GPS satellites move. And even if you set up with 3, sometimes they'll move and it'll drop down to 2. It drops down to 2, it loses coding. So you want to make sure you have at least 7, because that means if you lose some, you'll at least have 3, okay? The other thing is only use no sync when you're testing units indoors, or do GPS sync with holdover. Never ever use just standard GPS sync. And the reason why is this, is GPS sync with holdover allows you a 30 to 60 minute window where it still holds GPS resolution, and therefore if someone like a bird flies on a unit and they sit on a unit, and typically birds will sit there for about 5 minutes, then they realize it's kind of warm because they operate at around 50 C up to about 80 or 90 C, and they get too warm and they fly away. If you do that, you'll keep the units from losing GPS connections, but always turn on GPS sync with holdover, okay? And you know, as I just said, never use just GPS sync. That actually shouldn't be there, okay? Common feature set. First off, we have an embedded layer 2 switch. And so you can actually go with our unit straight over to over the network to a 90 watt PoE injector, over to the radio, over to another radio, and power 2 radios off of one connection. Or you can use a 90 watt PoE injector that goes over to one of the radio, and they can power up to like a T265 that can power PTZ cameras, which were literally impossible before because it just took too much power. Now with the new 802.3 BT standard, type 4, it's really incredible and it works out really nice. Okay. Other things that we have in Terragraph is the embedded layer 2 switch. It's solid, it works, it's a carrier grade switch. Power supply, it's everything is 48 volt PoE. And power consumption is really low. Like for example, the T260s and 261s are only 13 watts. The even with all the stuff, the T265 only has 27 watts. And for being a 4-sector device with a 10 gig switch, even the N367 at 47 watts is still pretty low. Environmentals are really superb. Everything is IP67, very solid, very reliable, okay? Accessories, I just put this in just so you kind of know this is the standard feature set, what comes with the various models. And then we have optional accessories, everything from the standard PoE injector for an N265 or any of the N367s, those need to be purchased. They don't, because especially on the distribution nodes, you can change what you're going to go. So you want to make sure you have the ability to switch out whatever power source you're going to be able to do it. We also make a couple other power source units that you can available for it. As far as standard mounting bracket, all the N367s come with their own mounting bracket. The N265 and T65 had their own type of mounting bracket, but especially when you're dealing with something with steep when you're talking about steep angles down or steep angles up, you can put the same mount that's used for a 614 or a T280 can be used on an N265 or a T265. It's the same mounting chassis. T260s come with their, and the T261s come with their own mounting bracket. And the T280, you do need to buy mounting brackets. It's essentially the same mounting bracket that you see on a 614. And then you also have, if you use a 1-foot dish on T280, keep in mind the T280 can go to 1-foot dishes. Therefore, it will actually use the 1-foot dish mounting bracket. All units will have either the standard, the optional one you can buy, which is for SFPs. We also have a conduit adapter as well. Okay. Other things is the 2-foot alignment tool, and you're going, wait, we're talking 1 foot here. If you do 1-foot antennas, you want to get the 2-foot alignment scope. We've made an adapter for it to work because the T280, especially with the 1-foot, takes some extra practice and a little more accuracy to work, especially when you're dealing with the 1-foot dish. We highly recommend that if you're doing 1-foot antennas, get the 2-foot alignment tool with the adapter, so it'll work with the TG 1-foots. It makes all the difference in the world. On the 6 inchers, the plastic tube works just fine, okay? Other thing is there's the WiNDE planning tool. This really works out so nicely in planning out systems. Right now, we've got the original version, which we've adapted to TG. There's a few hiccups there, and it works pretty well. There is a new version of the engine we are rapidly working on, and this is what consumes a huge chunk of my time, is working on this. It is probably going to be one of the most advanced design tools in terms of ease of operation, the ability to easily interface with Google Earth, whether importing data or exporting data back over to Google Earth. It works really nicely. And it can set up systems just on its own, or you can, again, interactively use it with Google Earth. It works really nice. Link budget calculator. Okay, even though we do have WiNDE, the LBC is still indispensable to determine link performance. If you don't use it now, please use it. It shows you a very accurate view of what a link will do in terms of performance. Also, this is what the document you're going to go to is this tool is what you're going to do to determine what your calculated RSSI, and this holds true for any T280s whenever you're doing, because that's a parabolic. So therefore, whether it's going to a multi-point unit like a N367, you're going to get a calculated RSSI. You also on any point-to-point links, you're going to use that as your calculated RSSI. It's really critical to understand it. If you don't have a good feel of how it works, give us a call. We can work through it. And the same thing with WiNDE. Give us a call, and we can help you with all of making that work for you, okay? So range and availability. Let's talk a little bit about that. So with range and availability, what you have is, and that's really what millimeter wave really has, is that it's all about availability. Whether you're talking about 100-foot link, 1,000-foot link, a mile link, or 5 miles, they all can go up to the maximum speed. The difference is how long it can stay up there. In other words, under what rain conditions, rain fade, and then long distances where it becomes critical. That's what it's about. It's the amount of availability, okay? And when you're talking especially E-band links, which are capable of doing multi-mile, and keep in mind with the 60 gigahertz stuff, you are just simply you're not going to be able to go ultra long distances. Part of it is because the natural decay effect of 60 gigahertz, which is a good thing. It's the reason why we have we can use it in high density environments and with very little interference, unlike 5.8 or other channels that it's just going to create, because the signals persist and they cause higher levels of interference. So what is the availability? So let's kind of look at this really quickly. So an 8010 link right here, this one is a 1-foot dish in Nebraska. Probably would only go in Nebraska right about maybe 1.2 miles with a 1-foot dish on an 8010 link. But keep in mind, its maximum throughput always is the same. Go here, now it can hold 10 gig longer. And what we did is we did the same distance with a 2-foot. Again, by increasing the amount of gain, because we're using a large antenna, we increase availability. It's not making the throughput any faster though, okay? A little different than lower band microwave. So key factors in deployment in setting those up is that what you want to make sure, and I've said this now before, it's a line of sight technology. You need to make sure line of sight. Having a branch in the way, no, doesn't work. It needs a line of sight. Also identify where your mounting points are going to go. You want to make sure it's a solid mounting point. You don't want to put a 1-foot dish on a wood pole. Why? Because a wood pole in the heat of the day will move. And all it has to move is less than a degree. And that will send your alignment completely off. In fact, you can actually, the torsional force spec on a 1-foot dish is 0.5 degrees. That's both torsional force and sway. And you can easily get, if you go anywhere beyond that, your link's gonna drop, okay? Like one of the major problems that people have is they mount to poor mounting points. Make sure you're using thick wall, not conduit. Make sure when you're using a 1-foot dish or 1-foot dish, at least 2 3/8, and we really recommend 3-inch, but make sure it's always thick wall. Make sure you're not running real long runouts with the pipe. Make sure that you can't feel any movement. With a 2-foot dish, it's even more critical that torsional force and sway is 0.25 degrees. That means it can't move at all. Roof mounts are really good for this kind of case. But, 2-foot dishes, other than on commercially graded towers, I wouldn't use it like on a standard Roan guided. Unless you're really good at guiding, I wouldn't put a 2-foot shot up there, okay? Grounding. It's important. It's a condition of warranty. It is, you know, we see this all the time where people ground to the pole itself that they're mounting to, which has no ground. The best thing I've ever seen is I saw a person grounding to their non-pen roof mount, which had a mat on it that insulated it, so it had no potential for getting any kind of ground, but they grounded the wire to the non-pen roof mount. It just doesn't work. You have to have really true earth grounds. We actually have a paper on that if you want that, on how to determine whether something's a true earth ground. You know, the other thing is get training on alignment. That's, you know, on aligning point-to-point lengths, multi-point, you have to align. You just ballpark them in and they work. On point-to-point, you do need to train alignment. And one technique we found that works really well is that you get a pair of tripods and try it at 50 feet, 100 feet, 300 feet. To quote out a integrator, they said it's a lot easier to make mistakes on the ground than it is in a pair of buckets. And it's very true. So just take your time, and also give your crews, especially if they're just starting out, make sure that you've given them time to do the install. The typical timelines for the first time a crew does it, you're going to be over 4 hours or right around there. Make sure you plan a 15-minute break. Let them take time, don't rush. The next one they do will be 1 to 3 hours. The third time they do it will be under 30 minutes. We've had crews that got so good that literally were just electricians, but they did enough and they were doing alignments in under 5 minutes. Okay, it's really key. Contact us for training information. We can help you out. We can put together, you know, trainings. There's also online trainings too that we have through e-learning. So take time so your folks, your teams can understand what's going on and they can do a successful deployment. Okay, the key thing is bench test the units, but, you know, don't throw anything from the boxes. This is so true with TG. All the time people will say, you know, that you have T280s, they threw them up and they threw away the box and they threw away the alignment too. Okay. Also look at upgrade the software, verify if you should do a factory reset. Not all cases you want to, especially the pre-programmed T280, the MPL series, which comes as a full link. Those are already pre-programmed. Don't reset those because they're designed so you can actually literally take them out of the box, put them up, point at each other, turn them on, and walk away. It's already fully pre-programmed. Okay. IPs, you know, you can do on the bench of the field. That's not a big deal because it's layer 2 radio, so we're not using IP addresses to route the traffic. The big advantage to IP addresses on the radios, it allows you to you know, IP in directly into that radio so you know which radio you're talking to. Oftentimes we recommend during construction is that you leave the default IP in there. That way if somebody fat fingers the new IP, they can always get in with the default. And then again, right before sign off, you remove the default IPs, okay? You want to do SSIDs, I can't stress this enough, after, again, it should be one of the last things you do, okay? Make sure you verify the distances with Google Earth, that's plenty accurate, but make sure you get accurate distances there, that's so key. The, you know, other thing in site installation is, you know, use the tubes, work with us on training. There's too much information here to cover within this training, but work with us, look at the quick start guide. We've got tons of information out there, but also you don't hesitate to call us either. We're here to help you, okay? A couple of examples here in systems that we work with, and this is kind of changing things a little bit. We've got a strategic partnership with Signify, which is Philips Lighting. We make, in fact, we're the exclusive manufacturer of their smart poles in terms of the RF connection systems. And by doing so, we can do it through, you know, you can actually hide stuff so nicely in radio heads, in lighting heads, or what's called luminaires. We also have smart poles and stations, again, all connected with us that Signify builds. And we can do that. So we've got a lot of resources that we can work with to really create and do things on a scale that it's that very few other manufacturers can do. And it really gives you some huge advantages. A couple of examples of what we've done is we've got in Kansas City years ago, they did have an area that had relatively high crime rates. And so what we did there was we put in a system with Access and Genetec, and was a competitive bid situation. We won the bid, and the system turned out better than they expected. It was essentially their crime rate in this area just disappeared, and it worked out incredibly well. Omaha Zoo, this one was for just a general camera system for the monitoring of their systems. Again, this is everything came off of this guy right here, the Desert Dome. We actually ran a 10 gig connection up there, and then ran a bunch of T280s, what are these units here, we ran those out. And they ran out over to a field of multi-point radios, and they went and they got connectivity into the various areas where they needed video for security and surveillance. The thing that worked out really nicely is they have a horticulturist that keeps cutting the fiber lines, and we actually got asked by their IT department, can we offload to your system if we need to back up our fiber? And we said, sure. It's only using about 1/10 of the capacity just for the video systems. So it gives them a lot of future options, what they can use. And things they've talked about is doing Wi-Fi specific stations. So you walk near your phone, it's just an open Wi-Fi system, and it goes, and it comes up and it'll talk about what the giraffes are doing or different things. So it gives them a real opportunity to do some systems that just simply hasn't existed in any other zoo. Okay. New York City Housing Authority, or NYCHA, Digital C, which is Digital Cleveland or Silicon Harlem. These are all projects we've done and put a lot of time and effort and work into. This is changing urban infrastructure, and we've been right at the forefront of this all the way. A lot of other people are now getting into it, but we've been here for over 10 years. Okay. Port of Long Beach, this and Port of, along with the sister port, Port of LA, we do both ports. They are the largest port, combined, they are the largest ports in the Western Hemisphere. Port of Long Beach exclusively uses our equipment, and they're actually right now, they've had their system in place for about 7 or 8 years, and they're now in the process of doing a full system upgrade again with Siklu. So it works out really nicely. Nuclear power stations, we do those too. All 6 Duke nuclear energy stations, we did the perimeter security system. We were the only system approved by the NRC for this project to do perimeter security with wireless. This system has been force tested by special forces. It works. They can't get around or jam. And that's really the thing, is jamming. Jammers are so prevalent today that if you're seeing like in shopping malls and you're seeing those units, most of those, if they're backhauling the traffic, they either have a cellular modem in there or they're using a Wi-Fi unit, both which can be easily jammed with a jammer you can buy from a Chinese website. And it's very available, and you're going to see this problem more and more. Nice thing about 60 gigahertz, you can't jam it. Not with a signal jammer. It just simply takes too much energy, plain and simple. This is a refinery that we did. Again, we've done this, and they're actually in the process of increasing what this network can do. Las Vegas, the Strip. The Strip is being completely converted over to Siklu by Ceragon. The whole Strip is going to run off of our radios. They looked at lots of other solutions. They picked ours because they said we're the most reliable, stable, and in their test systems we simply just worked. And we're way more cost effective than fiber. And they don't have to worry about fiber being dug up when they do new construction. HECO, we do both of their power plants on the island of Oahu. It was way more cost effective than fiber. In fact, the fiber they originally put in because the high vibration in the electrical plant, it actually broke down over time, and our system worked incredibly well. Vail, Colorado, we've been doing Vail. We did Vail originally about 8.5 years ago, and it's been upgraded several times since then. And we essentially took an existing Wi-Fi system that wasn't running very well, and they weren't getting a lot of throughput in the outdoor Wi-Fi, or the camera system wasn't working. We just backhauled everything on our 60 gigahertz. We retasked the Wi-Fi systems to just do, endpoint what they're supposed to do, which is like devices. And so then this was 8 years ago. You could go to the down, and still to this day, but 8 years ago, you go to the downtown square and get on your cell phone 100 Mbps connection. For that long ago, that was incredible. King City, California. This is another city that had a massive crime rate, highest murder rate per capita in California. Actually had more murders occurred here than in the city of Oakland. They put in a surveillance system connecting with our systems. We worked with the security service in locating a couple of points that could track with LPRs, license plate readers, who was coming in and coming out of the city, and it worked incredibly well. They went from the highest murder rate in California to 2 years later to a Safe Cities award. We're also using tons of airports. The largest airport in the world, Hartsfield-Jackson. We did testing with the FAA over at John Glenn International. In fact, they have our equipment now. Both airports run our equipment. We're in I think about 50 airports now just in the US. US National Mall, that's our radio right there, hidden on the Washington Monument. And we do a system that completely goes across the Washington Monument. We also do US Capitol as a separate system. And then we actually have several other systems going on in the DC area. NASA, when they did their 50th anniversary of the moonwalk, they found out a lot of their fiber didn't work, and they put in our systems, and it works really well for them. Thank you. Any questions, guys? Or did I just put everybody to sleep? I hear snoring.
Well, we got a yay, but I do not see any questions on here.
Okay. Well, I know several of these guys on here, so they've probably heard of some of this, but this is maybe a good review for them. And
Great.
and so any questions, don't hesitate to reach out to me, guys, and really appreciate your time. Okay.
Thank you, Tim. And as a quick reminder to our listeners, we'll be sending out an email shortly with all the information you just learned, as well as a video copy. So I hope you all have a wonderful rest of the day, and thank you all for joining.